Is on.
Awesome. So how you guys can get involved? It's going to be a little bit different because the internship that I got it's kind of due to a very special relationship that my college, the Rhode Island School of Design, has with the NASA Johnson Space Center, which is located in Houston, Texas. But I have some other insights into how you can get involved in with NASA internships and just other programs run by NASA. So hopefully that will be helpful for you guys. So a little bit about me. My name is Neha Saja, and I'm a senior at the Rhode Island School of Design, and I study industrial design. And some of the space-related stuff that I've done, up until this year, I was team lead of the RISD Rover team, and we're a team that builds and participates in NASA's Human Exploration Rover Challenge. And it's an annual challenge where colleges and high schools around the country and around the globe, it's an international competition, can build what's essentially a two-person recumbent bicycle. And then you build those, and then you fly to Alabama and you race them. And it was inspired by the first Apollo lunar landing and the kind of rovers that they used in order to move around the lunar surface. So like now when we're thinking about Artemis, they're looking for inspiration in these competitions for like tools that people design so that you can do like sampling, like when you get off of the rover, and then also designing rovers themselves that have good drivetrain and like really nice wheels and good treads, and things like that. And so that's one of the main things that I do that's space related, and participating in NASA challenges like that is a really good way for students that are in high school and in college to get involved with NASA and with the space industry. And I'll name a few more later on. The other thing that I did was I planned a conference with Brown University called Space Horizons. And essentially we invited a bunch of speakers in the space industry to come and talk to us, and we had roundtable discussions. That was really successful. I think like EG for Space is already reaching out and getting student speakers. And I think one thing that is a piece of advice I can give is that a lot of professionals in the space industry, and especially professionals that are working in NASA, are very passionate about like getting students involved. And so even reaching out to like specific scientists or specific like designers and engineers in NASA that are doing work that makes you excited, and being like, listen, I really am passionate about this payload that you've been working on. Would you be open to answering a few questions over email or speaking to me and a few students? They're really receptive to those kind of conversations, especially when the conversation isn't so much like, hi, I love you, please give me a job. It's more like, hi, I love the work that you're doing. Can you tell me more? They're really receptive to that. A little bit more about design and industrial design and the space industry. It's something that a lot of people kind of get question marks. They're a little bit confused. They're like, oh, so you're not an engineer. Not really. What design does in the space industry is have the ability to think about human interaction in these spaces. So designing, one project I did last year was designing a lunar habitat. And so working within the constraints of engineering and life support systems and how much food and oxygen do you need, but thinking about, well, how do these people move through this space? How do you design a space so that 4 people are essentially living in a tin can on the surface of the moon, and they have to get along and they have to work optimally and they need to be mentally stable? Like all of those things come down to being able to design a space that's separated properly and that has almost the illusion of personal space while being in a very contained area. And that's kind of where design comes in. And then even on a smaller scale, like designing like payload interfaces, like when you're doing these experiments, when you're designing these tools, if you design a tool just to get the tool done, that's great. But to get the job done, that's great. But if that tool can't be held properly with the gloves, the spacesuit, and can't like operate well, it's going to cause a lot of errors down the line, because the biggest risk to a mission is human error. So we want to minimize that. So I know people are interested in what I did over this summer. So I worked at the CDSA, which is the Center for Design and Space Architecture. And they're essentially like a conceptual and human-centered design department where they fabricate concepts and then they move from like CAD and to VR and then to full-scale fabrication and testing. And so it's just thinking about, again, like this is where they're doing a lot of work for like the Orion capsule. What I worked on was a concept ship called the Deep Space Science Vessel, and it's for a possible mission that's not yet an official NASA program that could take place in 2050 or beyond, which is for a fleet of long-term science vessels that would be in transit around like the inner solar system, and that would each one of them would house 48 people. So they're massive. And the goal of these vessels are to be able to do science in between destinations. Because when we think about the distance from Earth to Mars, what people are talking about is like just putting people to sleep or like all this stuff. But honestly, like you can do so much valuable science during that transit, and it's valuable time that would otherwise be wasted. So how do you think about the value of space not being destination to destination, but actually being in the vacuum of space, in that zero G, and doing good science, doing like experiments on the people, like how do people operate in those kind of long duration space missions? And so we took that concept and the constraints of like how big it was and how many people need to be in there and what food they needed, etc. And we designed the entire vessel and then 3D modeled the entire vessel. So there's full renderings and all of that, and it's in internal review in NASA right now. So we can't show any images, sadly, but once it goes through the review process, we'd be able to share it. Yeah, and so that's what I worked on, and of course we did it remote, which is very interesting. But normally people on that internship would have flown down to Houston and been at the CDSA. So I know a lot of you guys are interested in getting involved. And I mentioned the Rover challenge, the Human Exploration Rover challenge at the beginning. There's also a bunch of other Artemis challenges. There's the Big Idea Challenge, which is about designing lunar payloads, which is happening right now. One deadline has already passed, but I'm pretty sure you could email them and just send in a letter of intent anyways and get into that challenge. And there's also the Rocket Launch Challenge, and there's another challenge on designing suit interfaces. And these are challenges that are open to college students, graduate students, as well as high school students and middle school students. So they're really open. NASA loves talking to students and getting students involved. And they're really helpful because they teach you about the process of like taking an idea and actually making it solid, like coming up with a concept, a proposal, talking about science, doing research. And it's really interesting. So I would highly recommend getting involved in those kinds of challenges. You do it with a team. It's too much work for just one person to be doing by themselves. They're usually, I feel like, around 5 to like 13 people on a team. And then to actually get an internship, you do have to be a college student, and you go through the intern.nasa.gov website link, and all the internship links and applications can go through that website. Yeah, and I do know some college freshmen that applied and summer of their freshman year were actually able to do a NASA internship. So I would just apply early, just like put yourself out there, show your interest, and on your own time, like do your own projects. I don't know what college majors you guys are interested in, but like tailor your assignments and your projects to the space industry and just grow your knowledge base. And that's the advice that I would give. Yeah, I'll take any questions now, whatever. I was hoping to have some kind of a back and forth discussion. So we'll see.
One of the questions we had from before is, what is your favorite part of a mission to design?
That's a really good question. I would say my favorite part is like the initial ideation process, when you're not thinking about constraints and you're just thinking about possibilities. I was in a different class, I designed a Venus mission, And it was just phenomenal to be I was working with 2 engineers from Brown and just thinking about like, how far can you take an idea? Like throw realism out of the window for the first hour and really think as much as you can. And oftentimes you'll come up with an idea and you think, oh, that seems a little bit crazy, like we can't do that. But you do a little bit more research, and that initial like really open brainstorming will lead to like very fruitful places down the line.
The next question we had was, what do you hope to design in the future?
That's a really good question. It's something I think about a lot. I really enjoyed designing this habitat, this conceptual habitat. So I would be interested in working on habitation design, but I'm also very interested in medical applications in space. So I'm debating about grad school and other degrees I can get, but I'm very interested in thinking about when you've got long-term people in space, you're going to have to think about medical care in space. So how do you do zero-G surgery? How do you do these kinds of things? How do you like diagnose things when you're in space and you're away from all the facilities you have on Earth? Things like that is very interesting. And also crew quarters. Like how do you design a crew quarter that someone's going to be living in that's like the size of a small student dorm or even like a jail cell, and they have to stay there for 4 years or 5 years? And how do you design that in a way that makes it feel safe and like helps people's mental health?
The last question we had from earlier is, how competitive are the NASA internship programs?
They're very competitive. I know it's a worry that a lot of people have. One of the other interns that I was working with over this summer had applied for 3 years, I think, consistently. And he finally got on his 3rd year. So persistence is key. And also like making sure like when you're reading, this is probably advice you've already gotten, but when you're reading their prompt and their questions, like mimic their language back to them. So if they say we're really interested in mission architecture, like make sure you say mission architecture in your writing, because a lot of times when they're reading through like dozens of applications, they're looking for keywords. So think about how can you present yourself with these keywords that make you seem like a really strong candidate.
And that's all the questions we had for you today. So thank you so much for your time.
Yeah, of course.